Let us write, before an equation, we can even find moles. We can find moles of HCl reacted with calcium carbonate. Serious? Tunaweza pata hiyo? By saying 0.2 moles per liter. Okay? 0.2 moles per liter means 0.2 moles are in 1 liter. So, 32 cubic centimeters represent what? Simple cross multiplication. 0.2 times 32 over 1000. How many moles are those? Let's work out. 0.2 times 32 divided by 1000. What do you get? 0.0064. These are the moles of HCl that now reacted with calcium carbonate. Now, let us go back here. They told us that 50 cubic centimeters of 0.2 moles HCl were added from a burette to 0.8 grams of limestone. What do you get to understand from here? Remember, these are the moles that reacted. So, what we are going to do, we are going to write a balanced equation using this one to give us the moles of calcium carbonate now. Okay? Yes. Now that we have moles of HCl that reacted, why can't we just write an equation and find the moles of calcium carbonate? Okay? Yeah. So, moles of calcium carbonate that reacted. You use an equation. Calcium carbonate plus HCl. We know from our Form 1 knowledge that a carbonate reacting with an acid gives salt, water, and carbon dioxide, isn't it? Yes. What salt are we going to form here? Calcium chloride. And remember, calcium is divalent, so be careful with these formulas. Divalent means you put 2 here, because chlorine is group 7, meaning that it is monovalent. Okay? So when you interchange the charges, you get this formula. Then you have water and carbon dioxide gas. Write the correct state symbols. This one is in solution. This is in solution. This one is a solid. It's an insoluble salt. And by the way, when I introduced you to the definition of back titration, I told you it is used when the endpoint is difficult to find. Okay? Yes. Why are we saying the endpoint is difficult to find in this equation? This is an insoluble salt. So the reaction between this one and this one is very slow. Okay? It's very slow. Look at that equation. Is it balanced? What are we supposed to do to balance it? Since we have 2 chlorine atoms on this side, we can put 2 behind here. Isn't it? Yes. What else? Is it now balanced? Confirm. It's balanced. Okay? So from here we write mole ratio. So behind here we have 1 mole, and here we have 2 moles. So this is what I'm talking about. Calcium carbonate ratio HCl. We have 1 to 2, isn't it? The moles we got here represent what? 0.0064. They are moles of HCl. Place them under HCl. Good. Find the corresponding moles of calcium carbonate that were used. So you just take that value right by Divide by 2, isn't it? Simple cross multiplication. So it gives 0.0032 moles. These are the moles of calcium carbonate that were used. Alright? Yes. Given now that we have moles and the equation provides mass. So there. Yes. Can we get the relative formula mass of calcium carbonate in the sample? Yes. Relative formula mass means the mass of 1 mole of a substance. Okay? Yes. So, relative formula mass. Let me label this one number 7. Okay? Relative formula mass. This is mass of 1 mole of a substance. Understand that one first. Mass of 1 mole of substance. Okay? Yeah. So, from here, let us get the mass of calcium carbonate. What is the formula for finding mass? You take moles times relative unit. That is 0.0032 because we got them here, the moles of calcium carbonate that were used, times relative formula mass of calcium carbonate. Calcium has a mass of 40 grams per mole. Carbon has a mass of 12 grams per mole. And oxygen has a mass of 16 grams per mole, and there are 3. So we multiply by 3. What do you get? Work out 40 plus 12 plus this one is 48. 100. Now get me this mass. 0.32 grams, isn't it? This is the mass of calcium carbonate in the sample. Mass of calcium carbonate in the sample. Alright? And what is the sample? 0.8 grams. Meaning the remaining are what? Impurities. Okay? Good. So let us write the percentage purity. There, the question was asking, calculate the percentage of calcium carbonate in the sample. So this is number 8. Percentage purity of calcium carbonate. So we take the mass of the sample to represent 100%. Okay? Then the mass of calcium carbonate itself is 0.32. How much percentage is that? Just do the simple cross multiplication. You are going to get 0.32 times 100 divided by 0.8. Okay? This one gives you? What does this one tell you? That in this sample of 0.8 grams of limestone, only 40% is calcium carbonate. 60% is impurities. Okay? Yes. Thank you.